This is quiz 1 for Math 12 Pre-Calculus, summer session 2. Okay, the first question asks us to find the equation of the line that passes through 1, 1 and 5, 5. Now, no matter which form of the line I choose to put it in, whether slope-intercept form or point-slope form, I need to find the slope. So the first thing I'm going to do is I'm going to find the slope, rise over run. So m, my slope, is the difference in the y values of my 2 points. So that's 5 minus 1. I'm choosing 5 minus 1, those are the y values, over the difference in the x values, which is 5 and 1 also. Okay, so this simplifies to 4 over 4 or 1. Okay, so the slope of my line is going to be 1. Now I have the slope and I have a point, right? So I have actually 2 points, but I only need one of them. So I'm going to use point-slope form. Slope and a point, I use point-slope form. If I happen to have the y-intercept, then I would use slope-intercept form, but point and a slope, I'm going to use point-slope form. Okay, point-slope form says that y minus my specific y value, so here I'm going to use 1. I could have just as easy used 5 and 5, but I'm going to use the point 1 and 1. So y minus 1 is equal to the slope, m, or 1 here, times x minus my specific x value, which is 1. Okay, so this simplifies. So y minus 1 is equal to x minus 1. Now I'm going to solve for y. Y is equal to x minus 1, and then I add 1 to both sides. So y is just equal to x. So the equation of my line is y equals x, which if we graph that, looks something like this. Okay, so that's my line, y equals x. Now what is the slope of any line perpendicular to the line in part A? Well, just looking at our picture, we know that it's going to be the line with slope -1. That's the line that is perpendicular to this line. And it could be any line with that slope, with slope -1. So 2 lines are perpendicular when their slopes are related in this way. The slope of one of the lines is -1 over the slope of the other line. Okay, so if the slope of one line is -1 over the slope of the other line, those 2 lines are perpendicular. Notice this is just the slope. This doesn't have any x attached to it. This is just the slope of the line. Okay, so if I want my new line, the slope of my perpendicular line, to be perpendicular to the slope of this line, which has slope 1, then I know that my new slope, m2, has to be equal to -1 over 1. That's my slope of my original line, which is -1. Okay, so we get that the slope of any line perpendicular to the line in part A has slope -1. Okay, now part C asks us, what is the equation of the line perpendicular to the line in part A that passes through 2, 2? Okay, well obviously we know that since this line is perpendicular to the line in part A, that it'll have slope -1, okay? But it's also going to pass through 2, 2. So I have a point on the line, and I have the slope. So I'm going to again put it into point-slope form. So point-slope form says that y minus my specific y value, which is 2, is equal to my slope, -1, times x minus my specific x value, which is also 2. Okay, let's simplify that. So y is equal to, I'm going to multiply through by -1, and I get 2 minus x. So -1 times x, that gives me -x. -1 times -2, that gives me 2. So I get 2 minus x. And then I added 2 on this side, so I'm going to add 2 on this side. And that simplifies to be 4 minus x. So the line that is perpendicular to the line in part A that passes through the point 2, 2 is y equals 4 minus x. Okay, now the second question asks us, what is the equation of the circle centered at -1, 1 with radius 2? Okay, so the equation of a circle is x minus h squared plus y minus k squared is equal to r squared, where hk is the center and r is the radius. Okay, so our center is -1, 1. So where we see h, we replace with -1, and where we see k, we replace with 1. So if I do that, I get x minus -1 squared plus y minus 1 squared. Okay, now my radius is 2. So where I see r, I replace with 2. Okay, now this simplifies a little bit. X minus a -1, this is x plus 1 plus y minus 1. Now 2 squared, that's 4. Okay, so the equation of my circle centered at -1, 1 with radius 2 is x plus 1 squared plus y minus 1 squared equals 4. Okay, now can you explain or demonstrate how you can use the distance formula to find this equation? So all I was looking at is that you recognize that the circle is defined to be all points that are distant, the radius distance, so distance 2 away from my center. Okay, so let's just go ahead and write down what I just said. So on the circle, oops. So any point on the circle xy satisfies that the distance is 2. Okay, so the distance from any point x, y, okay, so that's I'm doing the distance formula. Any point on the circle is distance 2 from the center. Now let's remember our center is -1, 1. So we're going to use that to get the distance. So we get +1 here and -1 there. Okay, so that's just telling us for any point x, y, the distance is 2 from our center. That describes every point on our circle. The circle is defined to be all of the points that are distance 2 from the center. Okay, so 2 is equal to the square root of x plus 1 squared plus y minus 1 squared. Okay, now if we square both sides, we actually get the circle in its standard form. So this is called standard form when I have x minus h squared plus y minus k squared is equal to r squared, okay? So on the circle, any point on the circle xy satisfies that the distance has to be the radius. The distance from that point to the center has to be the radius. And then if we just square both sides, we get the circle in standard form. Okay, now problem 3 asks us to solve, and this was extra credit, but it asks us to solve to find the solution set of x squared plus 3x minus 4 is greater than or equal to 0. Okay, so we need to find points where we may change sign. Okay, now remember, these are places where either we get 0, so x squared plus 3x minus 4 is equal to 0, or we get that that is undefined. Now here, there's no place that this is undefined. If you think about this, the domain is all real numbers. I can put in any value for x and it still is defined because we've got this x squared plus 3x. There's no division by 0 or square root of a negative number. There's no problems with the domain. So there's no places where this might be undefined, but there are places where this is 0. Okay, so now right now we're solving x squared plus 3x minus 4 is equal to 0. Now we could use the quadratic equation, but this actually factors. It factors into x plus 4 times x minus 1 is equal to 0. Okay, so we factor this. Now we use the zero product property of real numbers to know then that either x plus 4 is equal to 0, or x minus 1 is equal to 0. Now if x plus 4 is equal to 0, then x is equal to negative 4. Or if x minus 1 is equal to 0, x is equal to 1. So one of those two things must be true if x squared plus 3x minus 4 is equal to 0. So now this divides our real number line into 3 intervals. Okay, so those intervals are 1 to infinity, negative 4 to 1, and negative infinity to negative 4. Now notice I'm just using these open brackets because afterwards I'm going to go back in and look at whether negative 4 and 1 satisfy the inequality. But to start with, I always just use those open brackets and then I check the endpoints individually. Okay, so let's draw our table. Interval, test point. We want to know what the sign of x plus 4 is. We want to know what the sign of x minus 1 is. And then finally, we want to know what the sign of their product is. Okay. Okay, so the first interval is negative infinity to negative 4, and then negative 4 to 1, and the last one is 1 to infinity. So let's pick a point that is in each of those intervals. So the test point I'm going to choose for this interval is negative 5. The test point for this interval is 0, and the test point for this interval is 2. So now let's just plug in and find out for those x values what the sign on each of these factors is. Okay, so when x is negative 5, x plus 4 is negative 1, which is negative. When x is 0, x plus 4 is 4, which is positive. When x is 2, x plus 4 is 6, which is positive. When x is negative 5, x minus 1 is negative 6, which is negative. When x is 0, x minus 1 is negative 1, which is negative. When x is 2, x minus 1 is 1, which is positive. So now the product here, we have a negative number. So when x is negative 5, we have negative here times times negative here. So a negative number times a negative number is positive. Okay, for x equals 0, we have a positive number times a negative number, which is negative. For x equals 2, we have a positive number times a positive number, which is positive. Now let's go back and remember what did we want? We were looking for when x squared plus 3x minus 4 is greater than or equal to 0. So we're looking for those positive intervals. So the positive intervals occur for negative infinity to negative 4 and 1 to infinity. Okay, but we're not done. Okay, so this is definitely contained in the solution set, but we need to check those endpoints, negative 4 and 1. So when we plug negative 4 in here, if we remember back to when we factored it, we've chose that number because it makes this expression 0. So when we plug in negative 4, we get 16 minus 12 minus 4, which is 0. Now 0 is greater than or equal to 0 because it's equal to 0. So this point is good. Okay, so I'm going to star that one. Now what about 1? When we plug in 1, we get 1 plus 3 minus 4 is equal to 0. Now 0 is greater than or equal to 0 because 0 is equal to 0. So this one also works. So our overall answer, the whole solution set, is negative infinity to negative 4 inclusive, union 1 inclusive to infinity. Okay, so that is the solution set.